All right, we're waiting on a little bit warmer day to do some painting inside the cowl area before we button this up. But in the meantime, we can start working on the firewall. There's kind of 4 things I want to do to the firewall. So the first thing I want to do, as you can see, it looks like somebody shot the firewall with a shotgun, and there's just holes everywhere. Some of the holes are for mounting the heating and air conditioning unit, which was right here. Some of these holes are where they had wire clips or various things. Some of these holes are where they had a sensor cable coming through. For instance, here's the wiper area, but mainly these smaller holes, they're just where the factory popped through some sheet metal screws and it looks like crap. So I'm gonna be putting a lot of this fixturing back, but it'll be using a nutsert tool and some Adel clamps to make it look a lot nicer. And so what I need to do is come through it and flatten out some of these holes where they have dimples, like this one right here, and then come in and weld those back up so the firewall looks nice and clean. Part 1. Part 2, or Operation 2, Part A, is flattening these edges out. So I have a plate that kind of covers this whole thing and comes down and even covers over here. It's a AC delete plate. The car won't have AC for the time being. If in the future I go with a vintage AC unit, the whole unit is contained in behind the firewall, so I won't need this hole really to be back like that. So somehow either using some clamps or something, or cutting this off, I'll make this flush so that panel can fit flat against the firewall. Step 2, Part B, would be fixing these holes that the previous owner or somebody had cut out to make some non-standard AC unit work, which never actually worked. So after I get this all flat, clean up that edge, make some patch panels. Step 2. Step 3 is, in the future, I don't have any specific plans for this, but this is where the top piece of the front clip attaches, one of a couple locations. And it's also a location where I may end up coming off of here with kind of a abutment, piece of metal that will come out and then come down over here to where the frame rail will be for the front subframe, to kind of get a triangulation to stiffen up this whole front box section. And so if you can note, there's only a few little welds. There's a weld here, there's a couple of spot welds here, there's a little weld here. And if I'm going to use this as a structural mounting point, I just want to go ahead and I'll probably come in and finish up this weld here, come around and seam weld at least this part of it. Maybe use these holes to plug weld, just to really reinforce this. So if I end up making a piece that comes out and reinforces that and kind of triangulates the subframe, I won't worry about pulling this piece off. And then Part 5 is down here. Part 4, sorry, is down here. This is where the brake booster, or the brake booster, sat here, and so the brake push rod came through here. This is where the clutch cable fixture came. Now the clutch is being converted to a hydraulic clutch. So unfortunately, it's a very different shape, and it's not a GM hydraulic clutch. It's a Tilton, I believe, or something. I'll have to double check on that. But essentially, I need to completely change the profile of this, which may include, basically, I'm probably just going to make a plate that is the right size, put it over this, weld it into place, and then hopefully that'll fix that problem. All right, so I need to come in and flatten some of these holes. You can kind of see here and here and here. A lot of these holes are dimpled because they're pressed in, or they're otherwise just flattened, or they're just where sheet metal screws have been punched through. So what I'm going to do for the ones that I can reach, like this one I've already done, so I'm just going to take this welding clamp and I'm going to stick this back behind here. So I've got this one, which has got a nice pucker to it. I'm just going to take this clamp and run it up tight against it, and then just start tightening it down. I'm going to loosen it back up. Helped a little bit. We'll give it a couple more tries. What I'm trying to avoid is going in and having to hit this with a flap disc, because the less material around that hole, the harder it's going to be to weld. So that's why I'm trying to use this technique, which I've never seen before, but figured it might be worth giving a try. We worked on some of the thinner areas of the firewall. Okay, that's a little bit better. It didn't really push it completely down, but it leveled it out a bit, so I think I may have to go in there and hit this one with a flap disc. I'll give another one a try over here. It's a little bit smaller one. This is definitely where a sheet metal screw had gone through to hold something. I don't recall what. Okay, yeah, that's a little bit better. So that's got it a little bit flatter, a little bit less metal to work on later. So I'm gonna go ahead and do that with the rest of the firewall, at least where I can reach it. Where I can't reach it, I'll try to slide a piece of metal up behind there and beat it flat with a hammer. Well, the clamp didn't work as well as I'd hoped for some of these more substantial divots, but I did end up going through and just kind of with the flap wheel being gentle and knocking them down and getting back there with a piece of metal and kind of working the whole firewall flat. It's not perfect, but I'm not going for perfect. It'll just make it look a lot nicer. But the clamp is really working well to kind of push this edge down. And I just wanted to show you a couple of examples. So I'm kind of going through here. I've already done this section right here, and you can see it's not perfectly flat, but it leaves what looks like a little bead roll, which I don't really mind. It'll be covered and keeps it a little bit more stiff. So kind of coming through, and the factory press makes it almost a 90. So I'm kind of working my way down the edge here with the clamp and just kind of bringing everything down to like 45, just going about halfway at a time so I don't tear the metal. And then just kind of working down this way, you can see that it's starting to bend over. And number one, it prevents me from having to cut it necessarily, which is always a pain, and then you lose metal and material. And it prevents me from having to like do a bunch of beating and shrinking with a hammer and a shrinker, which I already mentioned that I do not have. But this is working awesome. So definitely highly recommended if one of you guys are putting a AC delete plate on, want it to sit flush, just grab one of these welding clamps and go to town, because it seems to make the job super easy. The only thing that I did, which I probably, looking at how it works, I didn't have to do, is I went in and I had cut slits where we have turns so that it kind of relieved the metal. And I'm not sure I would have had to have done that, but that's okay. So finally, something working out. Here we just got about everything ready to go to do some welding, with the exception of the clutch plate, which we will do, the master cylinder clutch plate, which we'll do later, or at least not in this part of the video. You can see I've got a couple of patch panels made out here. They don't obviously perfectly represent what this would have looked like, but that said, I've already bent the flange over and this is getting covered with the plate. So this is really just to preserve the structural integrity and close up the hole. Good tight fitment all the way around, tight fitment down here. So this will be seam welded in just like it was down there in the corner. I finished using the clamps to flatten this out, and it turned out really well. Over here I did a similar thing. I ended up cutting several reliefs and then bending it over. So that's pretty nice and flat now. I went through and flattened out these holes where I could. Went in behind the firewall and cleaned up so there's no paint back there that's going to bubble through and contaminate the weld. To do the welds, as I had showed before on the previous video set, right here where it was really thin, I had to use a backing plate. So I'm going to use this little nifty tool that I found online. It's basically got a copper foot, and what you do is from this side, it'll be on the back side. On this side, you basically put it there. There's a clamp, or there's a magnet, and you tighten this down, and it presses this copper foot up against the back of the hole. So if I do it on this side, you can kind of see it there. There's the copper foot, and what it's going to do again is it's going to help that the argon gas not escape. So it'll do some back shielding. It'll also allow a little bit of structure for me to try to reconstruct that hole without actually having to put a patch there. So I'm going to give that a try, and see how that works out. I can't get this little fixture in everywhere, and so places like up here, there's some additional metal back there and it's really narrow, so I'm gonna have to come in there and kind of slide this piece of aluminum, which will serve the same function as the copper, clamp it into place, and cross our fingers it works out. Quick check-in on progress here. So you can see we've got these 2 panels welded in. Those are the raw welds. Haven't done anything to profile them down. Got a little bit of a mouth still here, but this is just one of those cases where I know, you know, leave well enough alone, stop while you're ahead. Because if I keep trying to make this close that gap, it's just gonna blow it open. So I'll probably just take a file and round that out. Everything else looks pretty good, just to get all profiled down. I also wanted to make a point. I've gone ahead and done some of the plug welds here, 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 and here, up there. This is just kind of a test case because I can have good access to the back of this. So use the little backing plate fixture. That worked pretty well. It stayed in there. I was able to get in there and build up some weld, kind of work my way around the circumference and then work towards the center. Didn't really have any problems with blowing through. I was running about 30 amps. Again, this is about 20 gauge material. The one problem I did find is after I was done, when I looked around the back side, it had domed out. So it made like a dome. And so when you looked at the back, there was a crater. Well, the problem is I'm going to come back on some of these, probably on most of these, and profile these down flat. So they'll fit behind the panel and just so they look a little nicer. But if there's a dome and a crater and I start profiling this down, I'm going to blow a hole through the middle of it with the flap wheel or whatever I'm using to get through it. So what I figured out is that you take the backing plate away after you've got the metal kind of in there, and then you turn up the amps. I had it up to about 45, and I just kind of worked my way around the puddle and kind of brought the whole puddle up to temperature. And without that backing plate there, that whole puddle kind of moving around together, what it does is it kind of equalizes on the front and the back. So this is a lot flatter than it was when I first did it, but I'll just point out as I move around to the back here, this is the back side of those welds, and they look like little domes on the back too. And so by doing that, I was able to actually get that to work out. So that's a method I'm going to try. So kind of a 2-process part. First, get the metal in there, cover the hole. Second, remove the backing plate, jack up the amps, try to get a little dome on both sides. Here's a shot of one of the larger holes in progress. You can see that I've got the little backing plate fixture in there. And at this point, all I've done is I've gone around the perimeter of the hole and I've just added material. So that means that the next row I'm gonna add inside of that, I have much less of a chance on blowing through. So the problem with this technique is that it builds outward slightly, like I was saying on the last clip, which means you need to address the crater that it creates behind it. But I just wanted to give you a quick in situ shot. And here it is with the next pass on it. And here it is with a couple more passes on it. You can see the next time I weld on there, I should be closing the hole up. And I will note that I am letting it cool down good ways between each pass just to give myself a little extra insurance that I'm not gonna open anything back up. But now that I've got so much mass on there, it's unlikely that it's gonna be a problem. So I'll go ahead and close it up. And here it is all closed up. So you can see it's got quite a bit of material on there, but it is concave. I'll try to get a shot of that before I try to fix it. Just general comments. The first pass is the most critical because you're working on that thin material. And so you kind of need to work fast. Don't worry about making the weld look good because you're gonna come back and mess it all up anyways. So just get the wire on the edge. Do not allow it to blow out. Work quickly, maybe at the cost of perfect dimes or whatever you want to call them. These are much smaller than dimes at this point. And then come back and add things on. It's much more important that you don't blow the metal out than it is to make a pretty weld at this point. And here's the back side of that weld. I've removed the little brass foot fixture, a copper foot fixture, and if I move it sideways, you can kind of start to see that it is cratered. And so if I tried to profile that down on the front with a flap wheel or something, I would just make another hole and I'd be back where I started. So I'm gonna attempt my little trick that I figured out on the other panel here, and let's see how it looks. Okay, so what I did here was, like I said on the other ones, when I initially put the metal on there, I was running at about 30 amps, for this one, since it's such a large bit of metal, I basically jacked it up to 50 amps, and I sat there and I worked the arc around this, just kind of in a circle, just heating up the mass. And you see at a certain point it gets liquid enough that the whole puddle liquefies, and you can actually see the top of the dome kind of deflate. It's almost like you get it liquid enough that it succumbs to surface tension, and it just becomes a blob equal on both sides. So you can see it's much lower now. Now what I'm going to do is go check on the inside, and hopefully we will see that there is no longer a crater back there.
And lo and behold, there is not a crater. Now on the backside, we have a really nice, gentle bump. No observable crater. We should be able to profile that down on the outside, and unless there's a cavity inside this bump, I don't think we're going to have a problem. So there you go. There's your trick on plugging holes in sheet metal.
I went ahead and flatted out a couple of these that I had already kind of finished up, just to check to make sure there wasn't any cavities. And you can see here's one. There's a couple little fingernail impressions here, and that's just because the area around the hole was dimpled. So when I filled it up with metal and then I started sanding it down, I didn't want to go too far because I don't want to go real thin on the metal around it. I kind of came in and tapped this back out this way with a hammer to kind of prevent that. But I've learned soon enough in here that if you think you should stop, you probably should stop. So I'm stopping. Looks good enough for me. Here's another one. Looks pretty good. Again, it was a little depressed, so I hit it back out with a hammer and kind of cleaned it up. And this one looks really good. Didn't have to hit this with a hammer at all. This area was a little proud. So there were 2 welds here. Grinded it down. That's all good. So now we just got to do the rest of the firewall. I'm a little less than halfway through plugging the holes in the firewall. There've been a couple of spots up near this top edge I haven't been able to get my backing plate behind, either the little foot here or the piece of aluminum here. And so I was really worried about blowing through, and what I had been doing is put the backing plate and using the smaller rod, this 1/16 stuff right here, and trying to build up around the edge just like I was doing on the bigger holes, which I showed you earlier. But here I was really worried about blowing it out, so I tried something different. I used this much thicker rod. I think this is like 1/8 rod, and I just shoved the rod in there, almost completely filling the hole, and lit up on the rod itself. And basically that made a molten blob right in the middle of the hole. And then I was able to quickly work it to the outside and just basically sling as much metal as I can to keep it cold and allow enough material. And that actually worked pretty well without even having backing material. So I think for holes like this guy, which is still open, and like this guy, which I gave you an example of, it's still necessary to go around with a smaller rod and keep the heat low and work it kind of in a spiral fashion towards the center. But for stuff like this, it's faster and it seems to be working better just to get a big rod, shove it in there, light it up, and then fill it up quickly and be done with it before the metal even has a chance to blow away. So just something I'm learning as I'm going along. I got all the holes filled and all the patches patched. Ended up being about 45 holes all told. The smaller ones, I used that technique where I just kind of put a large filler rod in there and melted it in real quick. The bigger ones I had to go back and build out around the outside. And then I went back on these big ones like I'd showed before because they were cratered behind there. Went through and heated up the puddle so it could equalize on both sides. The reason I needed to do that here, number one, is so when I come back and profile it down, I don't get a hole in the middle, but also because these holes are actually pretty close to the holes where I'm gonna have to mount the AC delete plate. They're not perfect, so I couldn't reuse them, unfortunately, but they're close enough that if I don't get them flat here and flat on the back side, it's not gonna fit right. So the next step is to go through and use a soft pad and clean all this stuff up. Almost done with the firewall. So what I was doing is I had a lot of welds to go through, and some of them had a significant amount of material. So what I started doing was using the flap wheel on the 4.5-inch angle grinder, my trusty 15-year-old Harbor Freight. I think I got it for $5 with a coupon angle grinder, and that let me take off a lot of material. But what I found is if I tried to take it all the way down, I would start to make the metal around it thin, and then before I got there, I just switched over to this 40 grit soft pad on this die grinder, and then that allowed me to get a little bit closer in so I could get rid of those little fingernail impressions that are left. So like, I think I left one right here, for instance. So right here, you can kind of see where that was where the edge of the weld was. And I could keep working that and make it go away, but it doesn't need to be perfect. But by using that soft pad, I was able to get the vast majority of them to go away. Like, this whole thing was a mess, but once it gets covered with paint, it won't be so shiny and it'll look really good. So that worked out really well. I also went around in the corners, like I said, with a file, clean these up and rounded them out so that they don't have any stress risers, since this is going to be a stress piece. And the last thing I need to do is go through and seam weld this piece right here, and seam weld this piece right here. So if I decide to come back and use this as an extra brace for the front submember, then I'll be able to not worry about it ripping off the firewall. And while I had the soft pad out, I also went through and cleaned up that weld. So that's all looking pretty good. All right, so I've come through and I've added some weld to this guy. I did a plug weld in this existing hole. I did a partial plug weld here. This all has a bunch of seam sealer crap behind it, and it's really tough to get out. So what I ended up doing is using a map torch and just heating this up significantly to try to carburize some of the, basically to some of this sealant in here, so it would kind of at least outgas before I hit it with the welder, and then tried to get a wire brush up in there, and that worked okay. So I was able to get the weld there. Here, this was already blown open from the factory weld, and so I had to add a lot of material to kind of work that back together. And I was able to get a seam weld to go all the way down to here, and here the gap gets kind of wide, so I didn't want to keep pushing my luck there. Same thing over here. It was just a couple little like spots, and I've come back in and I've worked all the way around this, and this wasn't here at all. I've added that in, so that should hopefully strengthen that. On this side over here, there was nothing up here. You can see I had a couple of blow-throughs. There's something behind here, either a pocket of air or sealant or something, that was causing this to blow through, and after a couple of attempts I just gave up. So I may have to come back here with a MIG or something that's a little less sensitive to particulate and crap in the weld to just close that up. I was able to battle with it and get it to work down here. I used the torch method to kind of clean behind it, and that still didn't work that well, so it was really a struggle to get this on there. This had a little weld here, but pretty much the only original weld was right here. So I added all this, I added all that, and all of this. There was not a seam weld here. The nearest weld was this. And free structures lesson, if I take this welding rod and put it between the spot weld up in the top left and where the original weld was in the bottom right, you'll see that the hole where the front clip mounts was cantilevered. There was nothing on this side of this hole that would have held this thing in. And so now I've gotten the welds all the way around here and all the way around this radius. And so if you hold the line there from the tip of the weld to the tip of the weld, you can see now that the bolt hole is actually kind of encapsulated within the edges of the points of this weld. So it's just pulling in tension. It's not actually being bent in cantilever. So that should significantly improve the strength. And we're gonna stop messing with that for right now and call it a day on the firewall.